Okay, hello. So for those of you who don't know me, I'm Dom. I'm one of the other Kin 301 TAs. So we as TAs have all been struggling a little bit to get this graph out to you guys with the isokinetic data. And luckily, one of the other TAs, Annalise, was able to figure out how to best do this graph for you guys. However, we were not able to teach you guys some of the steps. So this is going to be your Excel help video, which will walk you through all the steps on how to do it and produce the correct graph. And then we will also be providing the Excel fill-in sheet for you guys so you guys can work directly on this Excel sheet and kind of plug and chug those answers as well in order to create your own graph. So we'll get started and I'll give you guys some tips and tricks along the way to kind of tackle Excel because it can be a little intimidating. So let's get started. So what we are going to do actually is just fill in what we know from the lab itself. So these first two columns, columns A and column B, you already got from your lab manual. So this I'm getting straight from the data, from the experiment, and you guys can kind of see what my formulas are up here. So for velocity, we're gonna start with 30, 60, 90, 150, 210, and 300, okay? Then our torque was also given to us. So those values are 193, 155, 172, 141, 111, and 41. Slight disclaimer, these values for torque are not the most usual. There are some discrepancies in these values. So our force velocity curve actually is not going to look as nice as we would like it. So you guys can blame Noah for his weird data. The next thing we're going to do is actually put these values into scale, because when you guys solved for it in class, you guys were getting power values that were really, really large, right? We'll actually do that first. So for power, as you guys know, it's going to be torque times velocity or force times velocity. In this case, and this is not always going to be the case, but for this lab, we're going to use torque and force synonymously. So that means although they aren't quite the same thing, we can use them a bit interchangeably in this lab. So anytime I say torque, I also mean force. And so although we are asking you guys to produce a force velocity curve, we're gonna make a torque velocity curve in this video. So we're gonna solve for power by multiplying torque times velocity. And there's a really easy way you guys can do this in Excel. You're gonna hit the equal sign. If you wanna do any sort of formula in Excel, you're gonna hit the equal sign first. You're gonna click on the torque column, the value in torque. You're going to do a shift 8 for an asterisk, and then you're going to click on the velocity column. So it's going to multiply torque by velocity. You're going to hit enter. It's going to calculate it for you. We love Excel. And then if you guys hover over this little box down here on the bottom, you're going to get this black cross. This is really convenient because you can hold down that button and drag and drop to fill in all of that data. It automatically applies the formula for you. So again, for this very first one, we can see it's multiplying these two. If we were to double click on another one, we can see that the formula was applied and it already automatically multiplied these two for us. So now we already have our power. And as you guys can see, these values are incredibly different. So when we try to put them on a graph, there's really no way they're going to fit on the graph because the just axes are going to be all out of whack, right? So what we're going to do is actually we're going to scale them to the peak values. So we're going to look at these values in terms of percentages, and that kind of gives it a more arbitrary value. So for torque or force, remember we're using them interchangeably. We're going to take the value and we're going to find our peak torque. So out of all these values, which one was the greatest? And I'll highlight it for you guys to see. But we saw that the greatest amount of torque that was produced was 193. So we can type it into that box. And what we're going to do is we're going to make these into percentages. So again, you're going to hit your equal sign. You're going to click your torque value. That's going to be this first column. You're going to hit the slash, and then you're going to divide it by our value of 193. And you get 1. Again, you can drag and drop, and it's going to automatically do that for all of those. As you can see, these are actually expressed as decimals, but we want them as percentages. So we're going to go back into our formula. And we're gonna actually put parentheses around these values to make sure we do that first. And then shift 8 for our asterisk, and then times by 100 in order to convert it into a decimal. And we got a nice decimal. So again, make sure you get that black cross, drag and drop, and it'll automatically convert it for all of those. Don't worry about the amount of decimal places you had. It's not a big deal. But if, again, let's just double check. We can see our formula. Okay, we did 155 divided by peak torque of 193, and then we times it by 100 to get a percentage, and we got 80% for that one. So perfect. Now we're going to do the same thing for power, but we're going to express it as a percentage of peak power. So if we're taking a look at these values over here, we can see that our peak power is right there. So we're going to type that over here. We're going to go 2, 3, and then we're going to go equals. Again, hit your power. Oh, we want it as a percentage. So parenthesis divided by your peak power value, which is 23 times 100. So express as a percentage, drag and drop. Everything is filled out for you. Okay, so that's how you do the actual calculation of the values. Now we have to produce a graph, which can get a little bit tricky, but it's okay. I'll show you guys how to put all of your values onto one graph. So to make a scatter plot, you guys are going to highlight your velocity, which is going on your x-axis, right? This is your independent variable. We're going to highlight that. You're going to hold the control button down, and then you're going to highlight your torque percentage. So I highlighted velocity. I held the control button. I think for Mac users, I have no idea, but I'm pretty sure you just hold command. And then you highlight your torque values, and that's how you highlight 2 different columns. You're going to go to insert. You're going to do a scatter plot, and you're actually going to connect the dots. So a scatter plot with smooth lines. And that's what your chart is going to look like. So we're going to label this one as torque so we don't get confused. And again, this doesn't really look like your typical force velocity / torque velocity curve because no one gave us weird numbers, but that's okay. And we're going to do the same thing for power. We're going to highlight velocity, control. You're going to highlight the percentage of power, insert, scatter plot, smooth line with markers. And this is going to be our power curve. This one looks a little bit more normal, which is good. We like that. So we have our torque and we have our power curve. You're like, but wait, Dom, we asked you guys to put it on one graph. How do we combine these 2 values or these 2 graphs into one figure? Well, I'll tell you. So what you're going to do is you're going to click on one graph. Let's say I want to click on the power graph. I'm going to Control C. I guess for Mac users, it might be Command C. Who knows? So Control C, which is I'm going to copy that graph. I'm going to click onto the torque graph. So I'm going to click on the other graph. I'm going to paste it. So Control V. And it color codes it and everything for you. We love that. So now we're just going to make sure we have our axis titles that you guys have to talk about, and then we have our legend, so it will tell me what's what. So if we click on it, this blue line, that's going to be our power graph, and if we click on that yellow line, it's going to be our torque graph. So make sure you guys are just relabeling these to the correct name, and then adding your axes with your units, and then titling your chart. So you guys are going to copy and paste this figure, make your own, don't use the one from this video, we will know. You're gonna copy and paste this figure into Excel, and then from there you guys should be able to, you're gonna copy and paste this figure into Word. From there you guys should be able to insert shapes, and if you guys aren't sure how to do that, you can go, and it's the same as it is Excel as in the same in Word as it is in Excel. So if you go to Insert, and you can go, JK, they don't have them in Excel. You go to Insert, you go to Shapes, and then you can just draw lines. So from the very, very peak of where your power is, you're gonna draw a line down to where it hits the torque curve. And then you're gonna draw a line across, and that's gonna give you the percentage of torque that peak power occurs at. And that is one of your discussion problems. So again, you guys are going to pick your peak power curve, which is right up there. You're gonna draw a line down, and then you're going to draw a line across, and you're going to tell me at what percentage does it intersect this graph over here. That should be a part of your discussion, and you're going to tell me, is that what we expected or is it not? So good luck, everyone. Please email your TAs if you have further questions, but don't email them until you try it yourself or you work with your group mates and you try to follow along. So this will be posted to your beach board as well as the Excel fill-in sheet. So good luck, and hopefully you guys can get it. So thanks, everyone. See you guys in lecture.